Hello and welcome. We are your hosts Sandesh and Anshuman. In each episode, we will pick one seemingly boring security topic and talk about the good, the bad, and everything in between. So join us for some fun, some conversations, and some super hot takes about all things security in the boring AppSec podcast.
Welcome, Anshuman. How are you doing?
I'm good, Sandesh. How are you?
I'm not too bad. Okay, so today I think is going to be a really interesting episode because it's kind of like a topic that everyone's frustrated about, like not just security people, but everybody who works with security people. And it's one of those topics where you just talk and talk and talk about it. Nothing really improves. And I think we're going to add to that by talking more about it. So let's talk about vulnerability management today, right? I mean, I think this is like one of those modern problems in security. I don't think this was such a big deal when I started in security, to be honest. There weren't that many vulnerabilities in general. There weren't that many scanners. I mean, there were some, right? But a lot of the detection was manual, which means the volume of vulnerabilities were lower. The attack surface was maybe a little smaller as well. But in the last 8 to 10 years, with automation and scanning becoming so good, we just have a barrage of vulnerabilities hitting us, right? And it just the whole field of vulnerability management is kind of become. So today I think we should talk about, how do you discover vulnerabilities, how do you triage vulnerabilities, how do you remediate them, how do you disclose them, and most importantly, kind of, what are some of the issues you'll face along the way, and what our opinions are on tackling it. So does that sound good?
Yes, absolutely. But before we get started, do you want to walk through what vulnerability management means or can mean to different folks? Or do you want me to do that?
I'll start with a very quick definition and maybe you can just tell me kind of what you think. I mean, very simply, it's the act of managing a bunch of defects that you discover. So you discover a lot of defects and you've got to manage them somehow. Because when you have only 4 vulnerabilities, your management system is Slack or email or spreadsheet, right? But when you have a slightly complex infrastructure, once you become a slightly larger company, you will have tens and thousands, if not hundreds of thousands of and millions of vulnerabilities sometimes, right? And it's impossible to apply common sense to manage them, right? Or just track them in a spreadsheet and get done with it. Kind of works till it stops working, right? So I think that's kind of the whole area of vulnerability management. It has like a life cycle and everything, and we'll talk about that. But that's like my very high level definition. Do you agree with that? And how do you want to add some nuance to it?
Yeah. No, I think at a high level, that's pretty much what my understanding of vulnerability management is. And if we were to dig deep into it slightly more, right, like the way I think about vulnerability management is that it's basically a program or a process in any organization that can be thought about in 4 different phases. And I think we've mentioned this briefly, but we can go into the details. So the first is vulnerability identification or discovery phase, where you run a bunch of scanners, tools, commercial, open source. If you have a bounty program, you receive vulnerabilities from the researchers, right? So the first phase, you can just think of all ways that you identify vulnerabilities affecting your applications and your infrastructure. After you identify is triaging phase or vulnerability, like how do you figure out if something is a true positive or not, if something is a false positive or not, right? So the triage phase is essentially, it can be a combination of automation using some tools and rules and whatnot, or it can be mostly manual, where somebody from the security team looks at each vulnerability that comes through and then triages it, right? And there are ways to sort of fine tune this process, and we can go into it a little bit more into details. But triage is basically assessing the impact, the severity that a vulnerability brings to an organization. After the vulnerability has been triaged, the third phase is the vulnerability remediation. How do you go about actually going and fixing the issue, right? And usually fixing an issue is not as straightforward. It involves multiple people, multiple teams. It involves, pros and cons. There's some compensating controls, which the organization could be having, right? So there's a bunch of factors that go into consideration before you decide how to remediate. And then finally, the final phase is vulnerability disclosure. This I feel is mostly an optional phase, and I think this applies to mostly companies that actually sell products that customers can install in their infrastructure, like you can think of like a server product or like an appliance which customers would install, which in other words, there's no easy way to update those kind of products remotely, or it's not really a SaaS service, so to speak, right? So in those cases, companies that build those kind of products, it becomes really important to disclose vulnerabilities once they've been fixed, because otherwise the customers will have no idea that they need to update their product versions or whatever. So that's really the 4 phases I think about it.
No, I think that makes sense. I have 3 points / questions for you, right? So first, on the disclosure stuff, the point I want to make is you're right that it's mostly for folks which are building appliances, but I think there's another place where disclosures become important is if you're any kind of regulated entity, right?
Yeah.
So if you're in California, if you've had a data breach, there's a data breach notification law in California which kind of forces you to disclose it. But even otherwise, I think if you have users and your users are impacted by a security vulnerability that you have, I'm putting my cybersecurity hat on. I would say it's a good idea to disclose it and talk about it, especially if there was an actual breach of some kind and if it was exploited, right? So I think disclosure is hard, and we should dig deep into that. I think it's not just limited to appliance tools, right? I think there's a broader range there. The second thing, I'll come back to that because I want you to weigh in on that as well. So the second thing I want to talk about is I kind of feel like vulnerability management is one of those areas where the security community has not done a great job, and I think everybody agrees with that. It's still a big problem for the last 7, 8, 10 years, and I think there's a lot to learn from data engineering teams, right? Because when you were talking about vulnerability discovery and what happens, you essentially said, hey, there are many different scanners or inputs for vulnerability. It can be bug bounty programs, it can be scanners, it can be manual pen testing, etc. And then they all come into some kind of a single place, and then you do some analysis on it, right? This is exactly what a data lake is. I mean, this is exactly how people kind of get logs from different places, do log correlation, get insights, take decisions. I mean, people make product decisions based on this, right? So I know security data lake is a thing that's coming up and stuff, so we'll not go into that. But I kind of feel like, every time I think about vulnerability management at a high level, I feel like this can't be such a big problem. But when you dig deeper, I find that many people are really, really struggling with it, right? So maybe there are lessons to learn from data science perspective on how to kind of manage vulnerabilities, how to think about this artifact, and see if some lessons can apply from there, right? But for this discussion, we'll talk more about kind of, how today people solve it and what some of the issues are and how we can solve that. But I think it may be an interesting study to kind of think about it as a data lake and figure out how we can solve some of that. That's the second point. Third point is, I don't know about you, but I know because I was in consulting and I know you were as well, people are really hung up on words, right? And I don't necessarily think it's wrong, because sometimes words have meaning, right? I mean, words always have meaning, but the way you say things, the words you use, the phrases you use make a big difference. So I know for a fact that, vulnerabilities, defects, findings, bugs, issues are all kind of like reused, right? All the time. So when we talk about vulnerability management, is it not the same as defect management? Do the definitions matter? Like, what's your take on that?
I think it matters, and I say that because in my world, a vulnerability is not essentially the same thing as a defect or an issue. And I say that because, if you think about the definition of what a vulnerability really is, it is something that can be exploited to cause something bad, or to, and this bad could be customers lose their sensitive data, organizations get hacked, and the reputation, is kind of whatever, like. So I think to me, that is really a vulnerability, is you find a defect, so to speak, but you find it in a way that you actually exploit it to do something bad. You can't really say that for a defect or an issue, I feel.
Yeah, see, the problem I have with that, and therefore when you say vulnerability management, is it fair to say you only care about exploitable vulnerabilities, exploitable defects?
Well, I think that's a different conversation altogether, right? Because
exactly,
yes, no, I see where you're going with this, right? Because there are obviously low-hanging fruits as well, that, like missing headers, missing security flags, whatever, right? Those are not necessarily exploitable, but they can be chained, so if we were to, think about an example, right? Cross-site scripting. Let's just go with that, right? If a session cookie does not have a HTTP only flag, right? It's not necessarily exploitable vulnerability by itself. But if you were to chain that with something like, you can steal the session cookie because there's no HTTP only flag, and then you can use that to exfiltrate data from a customer session, right? That the whole chain is a vulnerability in my world, right? So I think anything that can be chained or that can be a part of a bigger vulnerability / risk would be considered a vulnerability
Yeah. So I think, I agree with you, but I think here's where I think the security community loses the argument, right? So what you just said it's very hard to determine how likely it is, right? I mean, we all say, hey, there's nothing called hack proof. No matter what you do, you might get hacked, and all you can do is make it harder for the hacker and stuff like that. That's the narrative we always say, right? So if that's the case, then you got to first fix the things which are most likeliest to be attacked and which have the maximum impact. And we'll come to risk ranking frameworks and stuff like that later, right?
Yeah.
So, but the moment we say this, right, if you don't set this header and this happens and this happens and this happens, then you might get attacked. The way you said it was very convincing for a security person, but the way I said it is how a developer hears it, I think, right? They're like, are you kidding me? Like you want 7 things to come together for this one thing to happen, and you think that's really real, right? So I think that's kind of where we lose the argument. I think one of the things I try to do, and by the way, this is not a good solution either, and this is why this is going to be a frustrating episode, because we're going to talk about problems and then we're going to tell our solutions and then going to tell you that the solution doesn't work. Right? I think that's going to be the theme of this discussion. So, but let me do this anyway, right? So one idea is to say, hey, anything that can be exploited, and if it can theoretically be exploited, you got to go fix it. That's one way to do it. But I think the problem with that approach is you start entering the rabbit hole of, is it really exploitable? Like, what if I do that? Well, I know you said XSS headers and blah, blah, but what if I have some other headers? Then do I really need HTTP only? I mean, there's so many framework level headers which you can add in. You can add content security policy, which kind of makes it impossible to exploit XSS. You may still be vulnerable. So if you do that, then do I really need to fix XSS? Then the developer in you will come and say, no, that's not cool. You got to fix it at the source. So you've got to do output encoding. That's what's critical. So, okay, so if I'm doing output encoding, then why do I need to put headers, right? Then you say defense in depth. Okay, now we're introducing another jargon, right? So it goes on and gets even more complicated, right? So my solution to that, which also doesn't work, by the way, but I'll tell you why it doesn't work, is to say, screw exploitability. Only focus on things which are quote unquote the insecure way of doing things, and it doesn't matter if it can be exploited or not. So if you're writing if you're querying a database from code, and if you're using string concatenation to do it, I don't care if it has a user variable, if it has user input, you need to parameterize it, or you need to use ORMs. That's it. No questions asked, right? I don't even care how it is. So when that happens, then that's kind of where the whole secure coding guidelines and secure coding standards come. Then you can say, look, I don't care if you're if this can be exploited. I'm not even going to waste time finding out if it's exploitable. If this is insecure practice, you've got to fix it, and that's it, right? There are 2 advantages to that, right? Before we come to the 1,000 disadvantages, right? There are 2 advantages to that. One is that it's very simple, right? You got a set of security guidelines. It's easy to kind of detect these things because it's easy to write rules. It's mostly in code, or some kind of static analysis can get you these things, and it's simple to explain to developers, saying, hey, here are 10 patterns which are insecure. You got to fix these patterns. Here's how you fix them, yada yada. That's one. The second thing is the security team almost spends very, very little time trying to prove exploitability. And I think this is a good incentive, because the moment the security team has to prove exploitability for something to be fixed, sometimes what happens is they know this can be exploited, but they're not sure how. And they have to spend many, many hours trying to figure out how it's exploited. And theoretically it can be exploited. You don't need to prove it, right? But proving it is hard. So now what happens is that you set a precedent of saying, hey, until I can prove that it can be exploited, I'll not fix it. Now we're spending hours and hours on something that you know is true, right? And this is where I see a lot of people saying, hey, we run a static analysis scan, and then unless a vulnerability can be exploited, we won't fix it. So then they do a pen test to confirm it. I'm like, that's a waste of time. They don't do the static analysis. Then your static analysis is just a pen testing tool, right? So I think these are the 2 advantages of going all in and saying, hey, I don't care about vulnerabilities. I don't care about exploitation. I just care about insecure patterns in code, in configuration, and anything. And if it's an insecure pattern, then you got to go fix it. So that's kind of the advantage. The disadvantage, I think, is that it's just overwhelming, especially if you're kind of, if you're not starting at the starting, and if you don't start this when the engineering team starts, but you get in as the 750th employee, it's very hard. The amount of debt you'll have, you'll never clear, right? So that's probably and plus, of course, there's no risk management there. There's no which application do you tackle first. Should you fix like a internet facing application versus an internal application first? So all those things make it a little too overwhelming for developers, especially when you start in the middle of an engineering team, right? What are your thoughts?
According to me, I think it's slightly more nuanced than what you just explained. And, I totally agree with what you said, but I think the way I see vulnerability management is like it's sort of a journey, and this journey is different for every company and of different scales and sizes, right? I think what you described is, if you have some secure guidelines, we don't even have to get into the conversation of whether something is exploitable or not. You just ask, you become more opinionated as a security team, where you say, look, we have these secure guidelines and we want you to follow them, and we don't want to get into arguments or conversation where something is exploitable or not, because that's what we are saying, right? But I don't think that scenario sort of applies to smaller companies or smaller teams where, you're just burning, like there's so many fires burning. Your day to day is just kind of spent in making sure you're prioritizing which fire to deal with, right? And if that happens, right, like for a small AppSec security team, it is, in my experience, I haven't had a chance to come up with these secure guidelines, because more often than not, if I'm asking a team to fix something without having secure guidelines, because if you think about it, right, like in order to go to an engineer and ask or expect them to fix something, you need to have some sort of a policy and like secure guidelines which is agreed upon by multiple folks. And in order to build that muscle itself, you have to spend like a few weeks, if not months, right? And when the team is small, you don't have the bandwidth to go and do that, right? You would rather just deal with things that are actually exploitable, because that shows the risk, right? You can quantify the risk, right? Because if something is not exploitable, yes, you don't really have to prioritize that. So that's been my experience. I think for more mature teams, right, for companies that are slightly bigger, yes, I totally agree with you, right? If you don't have secure guidelines, yes, you're going to drown in vulnerabilities, and you're going to drown in, like trying to prove something exploitable or not, and it's just not worth the ROI. So that's been my experience.
Yeah. No, I'm with you, right? And in many ways, this is kind of the devil's bargain, right? So the one thing, I noticed in a company that I worked in, which I thought was super interesting, is that, when we started the security program, and you're right, when you start, the first thing you have to do is exploit stuff, simply because if you're the first security hire, going back to one of our previous episodes, you have to convince your stakeholders, and if your stakeholders don't already have all these security guidelines and everything set up, you have to convince them that security is important many times. And the simplest way to do it is to actually exploit something, right? Because then it becomes real for them, as opposed to theoretically talking about it. So what we did, and this was not my idea, so I'm not claiming any credit for it, is that one of the very senior management folks, right, who has a lot of credibility in the company, basically at some point in the first 3 months, when we were finding too many things and people were fixing it and there was exploitable stuff and all that, I think the direction given was saying, look, for the next 12 months, we'll focus on firefighting, but that ends on this date. There was a date, right? They're like, after that, we're going to move into a lot more preventive, a lot more better coding practices type system, where we don't really care about exploitability. So exploitability is fine until a certain time, but at some point we got to expect better from people, right? Yeah. So that's one point. So I think that's one way to do it. Doesn't work in every company, but it can work in some. The second point, which I think is interesting, is that the problem with this approach, with the approach that I recommend, is that your secure coding guidelines will never be perfect, right? Yeah. There are always going to be new kinds of vulnerabilities, yes, right?
It has to be evolving, right?
It has to. It's very hard to evolve though, because if a new vulnerability drops a weekend, you can't possibly go through all the process and update your secure coding standards in a weekend, right? So what ends up happening is that you kind of mess up the incentives for the developers, because let's say they followed every secure coding guideline and they did everything right, and then there was like a log4j type incident where they had to update things quickly. They can come back to you and say, hey, I followed all my guidelines, right? Why do I need to do this new thing now? Just because exploitable? I thought you said we shouldn't worry about exploitability. Right. Yeah. So now that kind of creates. I mean, this is kind of a classic why AppSec is hard and why there's no single framework that solves all the problem, a single tool that solves all the problem. But I think the point I'm coming to, and I'm thinking aloud here between what you're saying and what I'm saying, is that there are multiple approaches to it. You got to find one, but whichever one you find, whichever one you decide on, there will be there will definitely be pitfalls, and you'll have to like watch out for them and account for them, and there's no other way.
Yeah, I'll just add to that. I think regardless of whatever approach you take, right, whether you go with the secure guidelines approach or whether you go with whether something exploitable or not approach, I think, and I think we've spoken about this before, as well as having like an organization's buy-in in the understanding of risk and how do you calculate risk, right? Again, we can go into this whole discussion of how do we calculate risk, right? So if you want to...
let's go on.
Okay, cool. So one thing that I have struggled, and I still don't know what a good answer is, to contextualize risk in terms of a vulnerability or versus contextualize risk in the sense that, there are multiple vulnerabilities, let's say they are chained together, and that can cause a bigger risk to an organization, right? They're both risk, so to speak. A single exploitable vulnerability also can be a risk to an organization, and a series of vulnerabilities, if chained together in whatever way, can also bring risk to an organization, right? But the way you calculate the risk score can be entirely different for both the scenarios, right? And again, like the how you calculate risk is also very subjective. You can do the likelihood and impact. Like if something like you can have a matrix and then you can see how likely is vulnerability to be exploited versus what's the impact, and then you can come up with a risk. There are other ways and frameworks like CVSS and whatnot, right? So yeah, let's get into this a little bit more, because I'm really interested to know what your experiences have been, and if what I said, right, like how do you decide if something is fixing or not based on the risk score that you decide to calculate. Really interested to see what you think.
Yeah, so I think not a fan of CVSS. I know there's been some work recently to kind of come up with new kinds of vulnerability standards. I think Zoom has their own thing, and many companies have published and tried to make it better. In my opinion, it's a good theoretical discussion. But okay, this is, again, everything in this conversation is I'm going to make an argument and then I'm going to argue against it myself, right? It's like a weird topic.
That's what vulnerability management is. Yeah,
it seriously is. It's almost like I don't want to talk about it because I know I'm going to contradict myself. So what's the point, right? So I think there are two things which are really important for vulnerability management. It should be simple enough that people understand, and it should work for your company. And I think CVSS fails at both counts. Okay, CVSS is just far too complex for most vulnerabilities. As a security person, I cannot get it. But man, explaining CVSS scores to non-security people is just a pain, right? And it's not arbitrary. There's a lot of research and work that's gone into it, and it makes a lot of sense. But it's just doesn't. It's a hammer to kill a mosquito. Right? It's just too big a weapon for things which need to be simple, right? So I'm a big fan of simple things, but the problem with simple things is sometimes it can become simplistic. So if you say everything is just likelihood impact, there are things, when you say likelihood, what does it mean? It means, how big is that attack surface? So is it an internal application versus an external application? How easy is it to exploit? So exploitability comes into place. And then, when you say impact, you mean like financial impact, blah, blah, blah. So when you go down that way, you'll eventually come to CVSS.
CVSS, exactly.
Right? Right? So in the end, as much as I want to diss on CVSS, it's pretty well thought through, right? Yes. So again, but it doesn't work. Like it doesn't work for so many reasons. Like the scores are confusing. Like what is 9.3 versus 9.1? Then you say, then we're going to do red, amber, green. And then we're like, okay, can you just not do red, amber, green then? Like why do you need like scores and then red, amber, green and then definitions for it? So I think it can get crazy complex. So I again, like I said, my theory is always if something's too complicated, just get the simplest version of it. Even if it's imperfect, it's okay. At least people get it, right? So my sense is just do priority, like P0, P1, P2. Like if something's a P0, it's very well understood that there's something on fire and you've got to stop everything you're doing and fix it. P1, P2 can have SLAs, so that's great. Now the problem with that is who sets the priority. So let's say because the other issue with fixing vulnerabilities is how hard or easy is it to fix, right? So if let's say something's a P1, okay, not really. Let's say something's a P2, like not really a big deal, but it's a extremely simple change. It can just become a part of the next sprint, and you can fix it in no time. Versus there's a P1 vulnerability where the impact is high and the likelihood is whatever medium. It requires a architectural rewrite of the application. So now you're going to do what? You're going to pick the P2. That doesn't make sense because you're never supposed to pick a P2 when a P1 is available, right? So now that doesn't make sense. So then when this happened, a few really smart developers pointed me, I think, to GitLab's security program, which is pretty cool, by the way. Shout out to GitLab. They published their entire security program online. Not their list of vulnerabilities and stuff, but all their policies, all their standards. Great service, right? So if you do it, we'll link that in the show notes, but something you should absolutely take a look at. So there they have if I remember correctly, and I hope I'm not misquoting them, is that they have priorities and severities, right? And their point is, hey, the security team is good at figuring out how severe defect / vulnerability is, right? And then you can tell us why it's severe, and you can use likelihood and impact to do that. You can do CVSS to do that, but you don't get to decide what we pick up first, right? That is on the dev teams, because their point is that thank you for telling us, but anyway, we own the risk, right? The security team doesn't own the risk. The dev team owns the risk. And if I believe that, there's this Sev0 bug, which is really bad and which is easy to fix, then I'll pick that up. But if there's a Sev1 bug, which is hard to fix, and Sev2 bug, which is easy to fix, then I'll pick up the Sev2 bug. So therefore, they decide priority. So for every Sev, there's a priority, but there are some guardrails saying, hey, your Sev0 cannot become a P3, right? Like that mapping doesn't exist. And then I'm guessing you can enforce that in Jira or whatever, right? So that's another way of looking at it. But now what happens if the dev team, which is not very well educated educated in security kind of makes everything P3 because they're like, yeah, we don't care about security, right? Then what happens? Like then the security team is kind of like out of control, like not out of control, but they don't have any control over what gets fixed first. So what's the point of something being high severity if it's never fixed in a timely manner? So what's the point of finding something if you don't have control over when or how it's going to be fixed, right? So that is a problem as well. So coming back to the same point I said 5 minutes ago, I sound like a broken record now, is that every approach has problems. You just have to know what the problems are and account for it in your company. My bias is to have very, very simple governance structures and deal with the exceptions. Some companies, some people like having very, very complicated governance structures with all the edge cases baked in. So then anybody can actually run those governance structures as long as you understand the structure, right? So then what happens is that you don't need to rely on individuals and their judgment to kind of run the program. You just need really smart individuals to set up the governance structure. Then even if the individuals running it are not super experienced, that's okay because all the exceptions are in theory baked in. The approach with my keep things simple approach is that it works for like 60-70% of the cases, but there are going to be a lot of edge cases and you need like smart, invested, high agency people to be able to manage those exceptions in a reasonable manner. So again, it's a trade-off. In general, I think this whole risk ranking thing is crazy. The only thing which I think is wrong or comes closest to wrong is analysis paralysis, which is you keep endlessly discussing what CVSS, what risk ranking methodology to follow for months and quarters, and then you keep updating it and you keep changing it, and it becomes really hard. So if there's one thing I would recommend is that keep it consistent. Whatever you pick, even if it's not perfect, it's not going to be perfect anyway. Just keep it consistent at least for like 4 quarters, and maybe every year if you can update it. But even if it's bad, just deal with it for some time, because constantly changing how risks are calculated or how risks are ranked makes it very hard for people consuming it, right? So my recommendation is pick simple versus complex based on your preference plus organizational style. And number 2, whatever you pick, even if it's not the best, it's not going to be amazing anyway. Just keep it consistent for a long period of time, so you're not constantly chopping and changing. Does that make sense?
Yeah, it does. Yes, it does. And I have 2 thoughts to add here. Well, the first is, what you explained right now. There's you can look at it from a different angle as well, which is, whatever organization you're working at, there has to be like an SRE/infra team, right? Which I'm sure pretty much deals with fires all day, every day, right? There's going to be like Sev 0, Sev 1, Sev 2 bugs. And these could be security bugs, these could be availability bugs, these could be a wide variety of bugs. But the way these bugs are rated in terms of the priority and the severity is pretty well understood throughout the company. So if there's a Sev 0 bug in an organization, everybody knows that is the utmost priority. Like, you have to just drop everything and go fix that, right? Now, as a security team, you can build your risk framework in such a way that sort of aligns to how the infra team is calculating their severity, and that is one way of doing that. However, I think you mentioned that, but it's not that nuanced to keep into consideration the security impact, so to speak, right? So something that according to the security team might be a P0, if you try to assess this same thing with the infra whatever, right, matrix, that might be a Sev 3, right? So I think there's one problem there, right? You can sort of align with the org culture, but then you don't really the security bugs don't get treated the way they should be. The other way is to obviously go with your own way of calculating the risk and the severity, right? So the infra teams could be doing their own thing, but the security teams could also be doing their own thing. And I've tried both these methods in different places, and neither of them have worked, which again validates the fact that vulnerability management is very difficult, and that is why it's not been solved to the point where you can just say that, okay, we have solved vulnerability management, right? Anyways, getting back to my point of, if the security team tries to do it their way, I think the biggest problem is the engineers get confused, right? So if you as a security engineer, if you go to an engineer and say that, look, there's a CVSS, high or critical severity bug that you have to fix, the engineer will ask you questions, okay, but I don't quite really understand because I follow this matrix, whatever. So yeah, there's always going to be that problem. And yeah, I think people spend more time in discussing whether something is worth fixing or not, as compared to going and actually fixing it. Which takes me to my next point / question, which again is slightly controversial based on what I have spoken to my peers. Is I feel like security engineers should be able to go and fix engineering bugs even if they don't want them. I know most people don't believe in this, but I really believe companies like Facebook or Google, right? Like if you speak to the engineers, they have access to the code base and they actually go and make these fixes because they are skilled and they know the code base. I think that's how it should be. So if security team thinks something is P0, then they should be able to go and fix it. Any thoughts on that?
Yeah, look, I mean, the one problem I have in general is that applying big tech rules to the world. Okay.
Yeah,
so in general,
that's fair.
Like, so what works for, I mean, that, like a person I used to really respect. I don't want to name him because I don't know if he kind of he will like being quoted on this. But he says what works for Microsoft doesn't work for everybody else, right? Because Microsoft is Microsoft, right? I mean, they have these massive. So when you're a large company, you have processes and checks and balances for a lot of things, right? Which sometimes is slows you down, but sometimes it gives you a lot of freedom because you know that if you screw something up, there will be other checks and balances which kind of will catch that. Right. So the example you give in Facebook, I don't know how things work in Facebook, but my sense is that if you find a bug, you'll basically go fix it, and then there'll be unit tests which will run, there'll be integration tests which will run, and then if any of those fails, then your fix is messed up. If all those succeed, then that's fine. 90%, well, not 90, I don't know what the number is, but every engineering team I have seen does not have 100% unit test coverage. Right. It's just not a thing. Right. I think in theory you need to have that. Like I used to joke sometimes that the number one security thing, if you want to really solve the security problem, you don't need cybersecurity companies. Just make 100%. Just make, if a company has 100% unit test coverage, then you can make security testing to unit tests, which are actually simpler than doing pen testing and all that. And then your life is solved, right? Because you can fix anything, and you can be sure that if the unit test succeeds, and if all the testing succeeds, then it will succeed in production, right? No engineering team is that mature that I have seen. Again, I haven't worked in like FANG companies, so maybe the rules are different there. But that's kind of how I look at it. So again, it comes back to the whole org culture, org structure type thing. The reason I don't like security folks fixing vulnerabilities is because I think your assumption is wrong, right? Your assumption that security people can fix code itself is wrong because they can optimize for fixing the security issue. So if you have a straightforward SQL injection, where you have string concatenation and you just move it to parameterized queries, sure, you can go fix it. Right, but it's a slippery slope, right? What if there's a more complicated? What if there's like an authorization bug where there's an API which is which can be called without any with any role, for example, right? It's not a read-only API call. It's an API call which makes changes to the database. So really, only the admin and some other role should have access to it. But any authenticated user can call it, and that's obviously a security bug. You want to fix that. That's some kind of a Bola bug, right? It's a privilege escalation. So you want to fix that. So you go and let's say you're doing Django, whatever. So you annotate, you add the role names and say should only work for admins and leads. That will honestly, it will break something. And unless you are a developer, not just who can write the code to fix it, but also have the ability to understand what this will fail, it's a terrible idea to go on it. And then developers lose complete control over it because now they're like, hey, I don't even know who's writing code, why they're doing it, how they can fix it. So if they have the ability to do this, and then let's say production breaks, guess who's dealing with the incident? Not you.
Yeah.
Right? It's the dev team. Right? So my point is, I think, again, like I said, it's kind of the same thing as the vulnerability management thing, right? If you can get buy-in in your company to do that, if you have the security team who can do that, if your hiring standards are so high that you're able to do this, more power to you, right? If you have an outsourced development team, if you have an in-house security team, or if you have an in-house development team and an outsourced security team, then this doesn't work. So I don't think this works for most places, but it might work for some. And of course, I think last week GitHub Copilot kind of released a whole new thing, which essentially says if you find it, it's fixed. Right? So they basically, like, if they find a vulnerability, then they'll automatically fix it. And they have an aspect saying, hey, this doesn't work for all vulnerabilities and all that. But even if it works for 80% of the vulnerabilities, that's great, right? Yeah. But I'm not bullish on that either, to be honest, because I'm like, that 80% number, I don't know what the number is, right? So anyway, so to come back to your point, I think in theory, what you're saying makes a lot of sense. And I think a lot of people think about it. It gives rise to a cultural problem. And if that cultural problem can be solved, then sure. But again, that depends on the org culture. So there's no real point talking about it.
Yeah, no. And the reason I asked you that question is because I actually tried going and fixing vulnerabilities in one of my previous workplaces, and I failed miserably. And I wanted to share that, right? Because I think it's important to share our failures as well. It's not like we've only had successes. So in this one place, it was a smaller company, and they were dealing with this authentication problem for a long time. When I joined, I was super motivated, super passionate about I'm gonna go fix this authentication problem. I don't think it's going to be that difficult. And obviously, if there's an authentication bug that has been going on for years, years, there has to be something to it. I just failed to realize. Again, I just kind of had that, I don't know where that confidence came from. I just started looking at the code base. I started issuing PRs and whatnot, and I broke a lot of stuff to the point where I spent probably a couple of weeks on trying to identify the problem. Like, forget about fixing it. Just identifying the problem itself took me a couple of weeks. And after that, I had to give up just because I was drowning in like spaghetti code. Basically, it was a monorepo where, you know, there was business logic and database logic. Everything was all clubbed in one repository, and my mind was just blown. And yeah, man, it was one of my, it was how do I say it? It was a pretty humbling experience for me as a security engineer. That's when I realized, you know, it's easier to say that security engineers can go fix it, because yes, there's just not possible for somebody to just join a team and understand what the code is doing. And, you know, so I've learned this through the hard way is security engineers can only fix certain things to, you know, which is up to their skill sets or whatever, right? It's just not possible to go and fix everything.
Yeah. No, I think you're probably being kind of like humble, but at least you went and tried those things, right? I think the worst kind of security engineers are the ones who just look down on developers because they can't fix things.
Oh man,
quickly.
Those are the
They're
worst.
Like,
I hate them. Yeah.
This is an easy fix. Like, why don't you do it? I'm just like,
you know,
try build an application.
I have to say, again, I'm not trying to throw shade on anybody, but our consulting experience was, I wish somebody, when I was a consultant at least, I wish somebody had told me that, you know, we are not supposed to just find stuff. We're also supposed to recommend people to fix stuff in a way that they actually understand. And I remember the reports that we used to write. Finding stuff was awesome. We used to find all kinds of stuff, right? But the recommendations were so generic. And when we, you know, used to have these handoff calls where we explain to the clients what the finding was and how to fix it. And if the clients had questions or they didn't want to fix something, we were like, why not just go and fix it, man? Man, it's like, I wish somebody had told me how difficult it is to fix something again, right? And you learn that if you worked in a product-based company or whatever. So,
absolutely. I mean, the empathy is kind of like really hard to build when you're talking to a faceless developer somewhere and all you're doing is finding vulnerabilities, right? I mean, don't blame the consulting culture for this, because you're paid to find bugs, not to fix them. So it's okay. I in my consulting gigs, I've also worked on what's called like find and fix projects, where you kind of get embedded within a team, and then your goal is to go find vulnerabilities, fix vulnerabilities and all that. And I think that helped me because I did this in like a very old, I can't name the customer, but like a DC based, very old school government type customer, right? And I developed a lot of empathy in that process, because I'm just like, wow, it's a lot harder than it seems. And the technical problem is the smallest, right? I mean, sure, sometimes the code repo can be complex and all that, but just the people problem, the process problem is also kind of hard, right? Having said that, I will say this. I think it's good for security engineers to try and fix vulnerabilities, right? Yeah. Because I think it gets you like you said, exactly what empathy. You said, right?
Empathy.
Empathy is one thing. Empathy is one, and you understand how complex things are. And when you understand how complex things are, you tend to find more vulnerabilities as well. So, for example, when I was at BlazerPay, I had there was one person in my team who was like a fantastic developer. He was part of one of the few people who kind of built out some of the core backend engines, who moved into the security team, right? I mean, you like that kind of experience is worth its weight in gold, right? Because you unlock so many business logic things which you never thought were possible by understanding how the code works, right? So I think it's really important. So that's one. The second thing is, I think there are certain, and this I learned from a colleague, this is really not my original idea, is that there are certain kinds of vulnerabilities that you can fix without going into the detailed fix, right? So I think, so for instance, right, if you're having some kind of an issue, right, and it's in production, and this is a problem, and this requires some kind of a logical rewrite to do this, then maybe you can go update some WAF rules to temporarily stop it. Now, I am not a fan of WAF. I think among the most popular blog post I wrote was kind of shitting on WAFs, and I got a lot of heat for it. but the reality is that if it's a production bug and you want to do something, then you can kind of go fix it there, right? Or if you have like an API gateway and you can turn down the rate limiting way down for one geography because you think that's where all the attacks are coming from, that's okay. So fixing is very large. So let me put it this way. I think taking risk reduction methodologies in a controlled manner when you understand the environment is fair game for security folks. I think it's okay to do that. It's also you should again exert caution and be careful about it. But it's okay to do that. What is not okay is kind of just fixing a security vulnerability in code without understanding the entire business logic, right? It's pretty easy to understand a WAF configuration and how that will behave with an application. It's pretty easy to understand how an API gateway works and how that interacts with traffic coming in. But it's really hard to understand how the backend of a ride-sharing app was implemented, right?
Yeah.
So it's very, very hard to go fix that. So I guess know your level and stay there as far as fixing vulnerabilities go, right? Because otherwise you can just cause a lot of havoc, right? But it's a great point, right? I mean, I think this is something, I think security engineers who can't code don't have this problem. And you know the mid thing meme, right? It's like you're a beginner, you've never written how to code, you just learned pen testing, you'll never think about fixing vulnerabilities. You'll never say I'll fix vulnerabilities. Then you learn a little bit and then you say, oh, I can code, so I'm also going to fix vulnerabilities. And then you become like a deep security expert and you're like, yeah, I'm never fixing vulnerabilities. That's not my job. Right? So it's that mid-wit meme going, all the way again.
Yeah, I think it is important to highlight the fact, though, there are things like compensating controls. There are things that you can not necessarily fix an issue, but mitigate the risk that the issue brings. So I think it is in my experience, I've seen that security engineers don't sort of like even consider these sort of controls, right? Like compensating controls or things that you can do to mitigate the risk. And they just want engineers to go and fix something, right? So I think, again, empathy, I think one skill that I recommend any security engineer to build is like empathy. I think once you do that, you can go a long way, especially because that has helped me. You can build relationships, you can sort of understand, and you can see problems from an engineer's eyes, right? All of those things.
Yep. Yeah. So the summary there is, it's good to try and fix it, but don't actually fix it. Like basically,
if you can. If you can't, yeah.
You can. Yeah, just work with the developers and let them take the lead. If they're okay with it, go ahead and do it. But play a supporting role as opposed to kind of like an owner. Okay, that's cool. So I think we'll spend a lot of time on that. Another question I kind of wanted to get into is, obviously, no matter what stage you're in the security program, you always find new ways to find vulnerabilities because there's no, because of the old saying, right, that the hacker needs to find one vulnerability or one chain of vulnerabilities, and that's it. Whereas we have to find every possible vulnerability. Like that's the only way to be really secure. Now that's obviously hard. So you use different techniques to do it, to scale it. To SaaS, we use DAST, we use SCA, etc. And then every few years, there's a new technique that comes in, and it's a good thing. And then you try and do that as well. So now, let's say you're in an organization, you already have a reasonable vulnerability management system, and then you introduce a new scanner, a new assessment methodology of some kind, which brings in a new stream of vulnerabilities. How do you manage that? Like, how do you go about fixing all those vulnerabilities? What are your thoughts on that?
Yeah, again, this is one of those problems where I don't think there's like a clear answer to it. Obviously, first you would have to figure out what the process looks like, right? How these kind of vulnerabilities are discovered with whatever this new scanner you're introducing. How are they triaging? Like, how are the vulnerabilities getting triaged? And so first you have to figure out what the pipeline looks like, right? Or the vulnerability management lifecycle looks like for this particular new scanner. Once you've figured, I think the focus should be more on how do you prioritize. By prioritization is, how do you triage, right? Like, so let's say we go with Nuclei. Nuclei is DAST scanner, open source, built by a project Discovery. So we can just go with this example. So let's say a company is trying to implement Nuclei in their scanning pipeline. Now, if you have run Nuclei before, you know that it's mostly it'll help you find low-hanging fruits at scale, right? You don't have to worry about like missing flags and missing headers and whatnot. It's also really good at finding customized chain vulnerabilities that might be very specific to your organization, right? So I think understanding that tool, fine-tuning it, and trying to extract the maximum value out of it becomes really important before you even go and try to fix vulnerabilities, right? Because it's very easy to implement any scanner and then start seeing a bunch of vulnerabilities, but then that is not really solving anything in my mind, right? Like you have to figure out if it is actually providing value or not. So those are the things that I would recommend doing first before you even try to go and solve them.
Yeah, no, I think that's a good point, right? I think you raised an interesting point on prioritization. So just want to double click on that, right? I think a kind of a framework / method that worked well for me is that I think whenever you introduce a new way of vulnerability scanning, and this will especially be true in the first few years of your security program, is that you've got to differentiate between debt and new vulnerabilities, right? So let's say you scan your entire system, and then let's say this is January, okay, and you got like, I don't know, 300 defects / vulnerabilities. And then you also say, hey, going forward, this will be part of a CI/CD pipeline. So you're going to be like, let's say we integrated SemGrep into PR scanning, right? And you got 300 SemGrep defects in your backlog now, and then you're going to have more coming going forward. Right. So I think the way I think about it is that, okay, if something's a P0, really exploitable, very bad vulnerability, then sure, follow your regular vulnerability management process, get it fixed as quickly as possible, and so on and so forth. But for the vast majority, which are not absolutely critical, I think you need to have different SLAs for debt versus new bugs. So you can essentially say, hey, if it's debt, it's unfair to go say stop everything you're doing because I found a new vulnerability discovery technique, or the security team found a new vulnerability discovery technique, and all you have to do is go fix everything. And if you have SLAs of, let's say, 24 hours, 1 week, and 3 weeks for P1, P2, P3, then it's unfair to apply that as well, because that essentially now means you got to stop everything you're doing, right? So what approach has kind of worked well for me, and again, I'll tell you why this is where this can fail as well, is that you essentially say, hey, the SLAs for backlog is different from SLAs for new issues. So let's say there are 300 new issues. So for that, you keep that aside, and then say, hey, going forward, if you find a new one for some code change that you made or some config change you made, then that still has to follow the SLA of every other scanning technique, the immediate 1 day, 5 day, 3 weeks technique. But for the debt vulnerabilities, for whatever is in debt, for those 300, you can take like 6 months, right? You got to show us progress every month. You have to pick up some as a part of your sprint planning, so you can kind of reduce the number over time. So you can need like a burn down chart to, like, you need a plan to get it to 0, but you don't need to get it to 0 right away or follow the existing SLAs. That way, what happens is that, it gives the engineering teams a lot more breathing room to kind of fix these vulnerabilities. And at the same time, you're incorporating that discipline, saying, hey, this is a one-time exception for these 300 that we are kind of bypassing the SLAs, but going forward, you still have to do it, right? So in the short term, it can still be scary because you literally know that there are 300 findings which need to be fixed, but you're saying, yeah, it's okay, don't fix it right now, which can lead to an attack, and you'll feel very stupid if that happens. But at the same time, if you think about the long-term horizon, this is a good way of kind of introducing something new, right? Without completely disrupting, SDLC workflows and sprint planning and things like that. So this is something that's worked for us in the past. Something to kind of think about.
So that's interesting. I've never heard of that approach. So you're basically saying having different SLAs of different kinds of vulnerabilities.
No, for debt versus new bugs. So for example, let's take the example. Let's say you have like 10 repos, okay, in your GitHub. GitHub account, right? And let's say you want to start a static analysis program, okay, which you never had. So now what you're going to do is, let's say you chose SemGrep, and then you're going to run scans on all your 10 repos, right? And you're going to, let's say, you get 300 vulnerabilities, right? Now, if you go tell the developers go fix 300 vulnerabilities, you're basically killing their sprints, the next few sprints, because that takes a long time. You don't know what needs to be done, yada yada, right? Now, instead, what you say is that saying, hey, so we've done static analysis. Here are 300 vulnerabilities. Let's say like 5 of them are like absolute P0s. Yeah, so exceptions for that has to be fixed immediately. But everything else which is really bad, which needs to be fixed, you don't apply the existing SLA. You just keep them as backlog. And then you essentially say, okay, going forward, for every new change you make to the application, we're going to integrate SemGrep into your, they're going to become part of PR reviews. So for every PR, SemGrep is going to run. If you find a vulnerability, we're going to block the PR, and you've got to fix it before you push it to merge to master or whatever. But for those 300, we're not going to block your builds if you don't fix them. Instead, we're going to say, hey, come up with a plan. You come up with a plan to fix this in the next, I don't know,
so
2 quarters.
So it's like you're setting a baseline, right? First, like when you first run SemGrep, you have a baseline of vulnerabilities. Then, so now that the team is comfortable with the tool and the process, anything new, anything new is super urgent, but anything new follows the vulnerability management lifecycle. But anything existing, you can call it backlog, debt, whatever it is, baseline, right? That you are a little more lenient, and you optimize for progress over finishing it up, right? So for example, you say, hey, things have to be fixed in the next 2 quarters, and then it's like month 4, and there are teams which have fixed none of them. That's a problem, because then they're probably just waiting for the last minute deadline to do it anyway. In which case, you can just bring the deadline up to 1 month and finish it off now, right? But on the other hand, for teams which, and usually there are always teams which are which cooperate better, like which need a carrot and which need a stick. For the ones which need a carrot, what you should really be doing is saying, hey, as long as you're burning down on your defects and you're kind of respecting the priorities a little bit, that's fine. You don't need to get to it now. Like you will kind of like ignore the SLA for these 2 quarters for this vulnerability type only, or for this direction type only. So that way, as long as it's going down, like let's say one of those application teams have 75. As long as it's going down from 75 to 70 to 60 to 40 to 30, it's okay if it takes 6 months. But if it's at 75 throughout, then you may have to intervene, right? So, but then that becomes part of their SDLC now, like how
PR merge scans become part of their SDLC, and they don't need to stop everything they're doing, and they can plan better, right?
Yeah.
That's something that's worked. The only problem there again, is if one of those 75 vulnerabilities were exploited 2 months down the line, then you knew a vulnerability, you knew you had to fix it. You told them it's okay, don't fix it, and then it got hacked, and you'll feel really bad about it, right? So it's a trade-off.
Yeah, and talking about SLAs and like fixing things, I think this is a good segue into like vulnerability remediation. One thing that I'll share that has worked in my experience is, once you find vulnerabilities, once you attribute these vulnerabilities to the right teams and whatnot, once you assess the impact and severity, right? So let's say you've reached a point where the vulnerability is ready to be fixed by somebody and the person is aware of that thing, right? I think the challenge, and I'm pretty sure this is a problem in most companies, is priorities constantly change, the backlog constantly change, and something that might be P0 today might be P1 or P2 tomorrow for the engineering teams, right? So vulnerability remediation follow-ups becomes a challenge so let's say there's a P0 that came in, and then you have to fix it within a week, let's just say that, right? If the team does not fix it within that week, right, it is red flag for the security team, in the sense that we found something P0 and we failed to get it remediated either by the security team themselves or by working with the engineering team, right? But in reality, what happened was priorities changed of the engineering team, and there was no follow-up method, like so to speak. So one thing that I've seen work really well is, as soon as the due date is coming closer, so let's say something is due to be fixed tomorrow or day after tomorrow, there's you can build automation using Jira or whatever, where if the issue is still open, if it is still not been fixed, you send an alert to whoever is supposed to fix it, saying that, look, this vulnerability is coming to its SLA due date, and if you don't fix it, you either have to file an exception process, right, or you have to accept the risk. And I think when I was with Atlassian, we had this process completely automated, and it worked like a well-oiled machine, right? Like, I hardly remember cases where we sort of missed fixing P0s which had to be fixed, just because it constantly reminded the engineering teams when it was due, when it was supposed to fix, and if they knew that they couldn't fix it, they knew what to do, right? It was like the whole exception process was also completely automated. So I think when we think about automation and what are some challenges in the vulnerability management process, I think following up with remediations is one of the biggest challenge I've seen, and I think it can be automated and you should do it.
Yeah, no, I think that makes sense. I mean, it also kind of brings in how sometimes you may need program managers, again depending on this one, company culture, or more than automation, if follow up and stuff is mostly manual, but that's kind of an important point as well. You also said something else which kind of piqued my interest, right? So you kind of mentioned about once you find a vulnerability and prioritize it, right, which you're glossing over a very complex process right there, right? Mm-hmm. On how to prioritize, but more importantly, the one product that I've heard every 2 years, every 2 years, some startup or company says we do this, is this magic called vulnerability correlation, right? They're like, hey, you found an XSS in SAST, you found an XSS in DAST, we're going to magically combine them, and it's going to be one vulnerability instead of two, right? Does that freaking work? I mean, I haven't seen it work, but maybe because we don't know how to make it work. Like, I can't think of a first principles reason why it's hard to do, right? Or it's hard to automate, right? At the same time, I've never seen this work. So what's going on there?
Yeah, I haven't seen that work either. I think systems like Defect Dojo or anything to do with vulnerability aggregation, right? Could be there's so many tools. I think ASPM is this kind of new domain, right, where I think that is essentially what they're trying to solve, is how do you correlate vulnerabilities from different things. So I think I think sort of reaching a point where it is very easy to correlate a SAST finding to a DAST finding requires a whole bunch of effort, where you have to look at the code and then try to build a POC or whatever, right, to prove that it exists. Yeah, I don't think it's worth the ROI, frankly speaking. Like, if you can identify the piece of code, right, via SAST where something looks vulnerable, and if you can identify the endpoint which kind of supports that, that I think you've solved a bunch of security problems then and there. And I have not seen that anywhere. No.
Yeah, so I think maybe we someday on the show we should invite someone from one of these companies who are trying to do the ASPM stuff, because I think it's a fascinating space, right? Like I said, I can't think of any first principles reasons why this is so hard, but I do feel that this is kind of also a problem we've brought upon ourselves by doing so much scanning and kind of not prioritizing at the high level. Like, the one hypothesis I have absolutely unproven. I've never tested this. I was never able to test it when I was a product security engineer, and now I'm running a company, so I can't. Maybe you can. Is that I think we got to start looking for a smaller number of things. Okay. And again, I know that sounds crazy, so let me kind of reiterate what I mean, right? So, for instance, if you really care about availability, then I think all your tools should be tuned to find availability first and focus more on that than anything else. Let's say for a quarter or whatever, and only once you get the hang of it, you can move on to some other kind of vulnerability, right? And what that does is that if you have 10 vulnerabilities in your entire company, correlation is not a problem because the number is too small. The problem happens when you have too many vulnerabilities.
Yeah.
Right. It's kind of like if you're stocking your, I don't know if you're into cooking, but if you stock your kitchen cabinets with a lot of different kinds of grocery, now you're going to have a grocery management system, right? And then for the grocery management system, you need like labeling, okay? And the labeling has to be on paper, which does not go away when you wash those vessels. So you've got to use like waterproof things. Now you got to laminate the labels that you added so that it's just a mess. Instead, if you just order shit you need on whatever, DoorDash or Zepto, depending on which country you're in, the morning that you want to cook, right? Then you only have the ingredients in your kitchen which you need, and you don't need to worry about. Again, I know it's like a very please don't take the analogy any further.
It's actually a very good example. No, it's right. Like a grocery
market. It's a good example. Yeah. Right. So it's kind of a thing. It also tells you how old we are, right? So we're talking about grocery.
I know.
Right. But my point is, I'm like, I kind of feel like, again, this is a hypothesis. I have to think about this a lot more, and maybe I'll write about this on Boring AppSec blog someday. Is that I kind of feel like this leaving prioritization to the end is such a weird way of looking at things, right? You got to prioritize first, and every tool should be optimized for what is top priority for you. And for anybody who says you can't prioritize on security because because everything is important, I mean, sorry, you just don't know how to prioritize. This is the same philosophy of saying, oh, we can't measure stuff because it's too hard to measure or because it's subjective. No, I mean, if you read How to Measure Everything, I think it's a great book. You can literally measure everything, right? I mean, it may not be perfect, but it's a great proxy, right? Like the example I always like giving is, I'm like, hey, what's your life worth in dollar terms, right? And everyone's like how do you measure that? I'm like, you already measured it. If you took a life insurance with the sum assured as $1 million, then you put your life's worth as $1 million, right? You may not have said it that way, but that's a good proxy to think about what you think your life is worth, right? Sorry, I know that was a digression, but I think the point I'm trying to make is that leaving prioritization to the end itself, I think, is the problem, right? You do all the mistakes and then you want to prioritize. Instead, if you can prioritize upfront and say, hey, I'm going to only look for ABC kind of vulnerabilities because that's what's most important for me, maybe then you have less things to prioritize. And then maybe you don't have to worry about correlation that much because you have a smaller set to play with, right? It's like anything, right? It's even waste management thing, right? I mean, a lot of waste management is about how you segregate waste, etc., etc. But if you can just generate less waste, right, which is possible if you think about it, then you can probably, it's much, then waste management is not that big a problem anymore. I don't know if you've thought about this. I mean, this is just very theoretical.
Food for thought is basically try to prioritize as early as possible.
Correct. And look for things that are top priority instead of looking for everything and then prioritizing what to fix.
Correct.
Okay. Awesome. So just to quickly summarize, we kind of spoke about the 4 phases of vulnerability management, like discovery, triage, remediation, and disclosure. I know we didn't talk too much about disclosure, but we spoke about it a little bit earlier. And how each phase has trade-offs. And I think the key takeaway from this is that there are many techniques, tools, theories you can apply, but all of them are flawed in some other way. So the best thing you can do is kind of start with one, figure out what works for your company, and stick to it for a reasonable amount of time before you make too many changes. Okay. Excellent. Well, that's a wrap for today. Thanks a lot, Anshuman. Have a good weekend.
Thank you, Sandesh. See you next time.
Thank you for joining us. If you like the show, please share this with your friends and colleagues. If you have any questions or comments, you can reach Anshuman on Twitter at Anshuman_BH. That's ANSHUMAN_BH. And me, Sandesh, at Jubba on Jeans. That's JUBBAONJEANS. See you next time.